Hello, everyone. This is the first in a series of screencasts on Chapter 15 in our textbook on object-oriented programming in R. Now, this first screencast presumes that you have carefully studied already the introductory section on the object-oriented programming paradigm, this little discussion about objects in the world around us and how we conceptualize them. Because it leads to the fundamental idea, I think, of object-oriented programming. The idea is this, that since we are so used to viewing the world as a collection of objects that are constituted of various attributes and methods, and that are related to one another through membership in classes of varying levels of generality, that it might help us to be able to view a computer program similarly, as a collection of objects thus constituted and thus related to one another. And this screencast will begin the first type, the discussion of the first type of object-oriented programming, message passing object-oriented programming, which is what you'll find as object-oriented paradigms in most other computer languages. It's going to be much later before we get to generic function object-oriented programming that's more specific to R and to other languages in its philosophy family. So message passing, object-oriented programming. What I plan to do is just head to RStudio, where I have source file for this chapter of the book that will let me follow along, try out the code, and look deeper into some of the things that are produced by it. So I suggest that you also pull out an R script and copy and paste in a code and try it out in the same way as you go through this. So we're going to be taking advantage of the package R6 that gives us the ability to do message passing object-oriented programming in R. So I need to attach that to our search path. And, the world is full of these objects. What if we wanted to program about maybe persons in the Wizard of Oz? So we have this concept of, of a person in the Wizard of Oz and what things are important about them. In R6, you can create a class that you might call person. So I'm just going to go ahead and run this whole code chunk that binds the name person to the result of a call to the function R6 class in the R6 package. Here we go. There it is in our global environment. Notice the kind of thing it is. It's an environment of a certain sort. R6 accomplishes its object-oriented programming through a lot of tricks with environments. Let's talk about how we made it. We provided a name for the class, person. That doesn't have to be the same as the name you're binding, this object to, but it's conventional for it to be the same. And then, under public here, we have a rather long list of items that we want to be public attributes and methods for the objects of this class. Public means that any programmer can use them as long as they have an object that is of this class. These attributes will be accessible to that programmer in ways that we'll learn, and these methods will be things that the programmer can ask those objects to do. So amongst the public attributes are the name of the person, the age of a person, and the desire of a person, that being important. In the Wizard of Oz, everybody has a desire, to go back home to Kansas, to have brains, to have courage, and so on. There are other attributes that, because they are functions, they're more commonly called methods. So we'll always talk in terms of attributes, which are like values, like numbers and strings, and methods, whose values are functions. And one such method is initialize. And it's a method that's going to be called when we make a new, make an actual object of this class. So it's a function of name, age, and desire as parameters. Those are just parameters for the function. They're not these attributes here exactly. But they're related because what happens is when the function runs, self $name gets assigned to whatever the user said the parameter name ought to be. What's this thing about self? Self actually refers to the object itself. And what we're saying is that with the $, is that the name attribute of this object, when it's created, is going to be what the user specified in the name parameter of the initialize function. Same for the age and the desire. And then finally, this function is going to run its greet method. You see a greet method down here at the bottom, which simply involves catting out the paste of hello, my name is, with the name of the object, self $name. There's a couple of other methods, and these can be used by a programmer to set the age of a person and to set the desire of a person. So we'll examine them at work in a moment. But I want to make it clear that person is not actually an object. It is a class. You can think of it as the concept of a person, as opposed to an actual flesh and blood person. So, like, a person, this thing in your global environment right now, it really does. It's a pretty poor excuse for an actual flesh and blood person. Because, like, suppose you ask it to greet you, like person $greet. Okay, and let's see what comes out. Error. Attempt to apply non-function. Or how about, let's see, how old is this person? Person $age. Null. What? Real people have ages and they have names and they talk to you. This is not the same thing. Person relates to actual flesh and blood people in much the same way that, like, a recipe for a cake relates to actual cakes. Cakes have a taste, good or bad. You have a weight and so on. Recipes for cakes are just procedures. They don't have a taste and they don't weigh anything and so on. So in order to get, like, flesh and blood computer stuff to work with, I don't know if there's flesh and blood computer stuff, but in order to get computer stuff that really functions as persons, we have to instantiate objects out of this class person. So check out this next bit of code. Dorothy is person $new. And you might be like, wait a minute, new. Is that like an attribute or a method of person? I don't see it up here, like in the code for defining person. What's up? Well, if you actually take a closer look at person, over here in the global environment, just click on the little magnifying glass. And you'll see there's actually a lot more to person than what we specified in creating person. What we specified was really pretty much down here in public. Public methods, initialize, SetAge, SetDesire, and the greet. Clone also came in. That's not something we specified, but it seems to be another method that's, like, publicly available for anybody who's going to be a person. And there's also some attributes. The attributes for the person, I think, are under public fields. Yeah, name, age, and desire. And then there's, like, all this other stuff, that comes along with person and is provided by the R6 package when you create a class. And one of those is this method new, you know? And so that method is actually available for any class of objects. And what it does is it allows you to create actual flesh and blood objects off of the class. So that's what's happening in the code down here. So I'm going to run it and see what happens. So we get Dorothy over here in our global environment, and we also give a side effect out to the console, hello, my name is Dorothy. Why did we get that side effect? Well, checking into the programming for initialize, we notice that self $greet is called at the end, and self $greet does cat out, hello, my name is, whatever the name is. So apparently part of what the new method does is that it automatically looks for this initialize function. And if it's there, then it runs it. And it creates an actual object over here in the global environment. And so if we take a look at this object, then we see like such things as the name and the age and the desire of the person. We see the initialize and the SetAge and setDesire methods, as well as the greet method. We don't see much else except for the enclosing environment for the object, the environment in which the object was created. But because all of that, the other things that a lot of the other things that an object can do kind of come along with the class. Notice clone comes along. We'll talk about clone later. And that comes along with any object because of the programming of the R6 package. You don't have to provide it. Okay, so like what can Dorothy do now that she's a real flesh and blood person? We can print her to the console and kind of get the same look that we got. But in a minute, we'll see, that we can do such things as change the age of Dorothy or change the desire of Dorothy. While we're at it, why don't we just create another person? You can instantiate as many objects as you like off of any class that you've got. How about Scarecrow here? Person new. Name is going to be Scarecrow. Age is 0.038, which is 2 weeks in units of years. Desire is brains. Off he goes. There's Scarecrow. Hello, my name is Scarecrow, he says at the end of his initialization. So let's do some things to say Dorothy. I believe she started out at age 12, but what if she becomes 13? You might say Dorothy $SetAge 13. So we're calling up that SetAge method in the Dorothy object. Let's see what happens. We get a side effect. Age of Dorothy is 13. Let's check that out. Back in the code, sure enough, in SetAge, there's 2 steps. The age of the person is going to get set to the value provided, the 13, and then we're going to cat out age of name of person is that value, just so the user can know that their setting actually had an effect. You can also tell the setting had an effect because if you ask for Dorothy $age, it's now 13. Now, you can totally just set the age directly. You can say Dorothy $age is 14. There it goes. And you don't see anything in the console because the SetAge function was not called up, so there was no cat call involved. But you totally get the effect. Dorothy age is now 14. So the idea is that whenever you want to call a method on an object, you just say object $method. This $sign is always, or conventionally meaning in R, get to this part of a thing. So you're getting to the method in inside the object and getting it to do something. And we can have Dorothy greet us, and we get the hello, my name is Dorothy. And if we'd have done more programming in the creation of the class person, then we would have got persons who could do more things. And you might wonder, can we make persons do more things now that we have created this concept of person? And the answer is yes, and we'll see how later. But along the way, I want to point out to you a little a side topic that's very important. And that's that when you're working with objects, that the semantics for them is very different from working with other types of data structures in R. Objects operate by what is known in computer science as reference semantics. And that means that when you're using the assignment operator, to assign an R6 object to a variable, like binding the name Dorothy to person $new, that little variable, like that name up here in the global environment, Dorothy, it holds a reference to the object. It's not really bound to what you might think of as a copy of the object, the object itself. It holds a reference to it. And this is in contrast to value semantics, which is pretty much how everything else works in R. Well, where most other things work in R. In value semantics, a distinct copy of the value is created and stored in memory, and the name gets bound to that value. And that new name, it refers to that copy over in memory, reference semantics. So, the value semantics. So here's an example of value semantics at work, kind of like in the old way, this is the way we're used to things working. You could bind the name A to 10 over our global environment. There it is, it's 10. And then you can say, I'm going to bind the name B to the result of evaluating A. And so sure enough, B gets bound to 10. But now I changed my mind. I'd like to bind B to 20. And so now it becomes 20 over in your global environment. And hey, what's A now? Let's evaluate A. And, well, the console says 10. And so, what A is bound to was not affected by your decisions to set B to 20, to bind the name B to 20. And so we're used to that, and we expect that. That's value semantics. And you can see it at work, really, if you make use of some functions from the pry-r package. Pry-r, like prying R open to see how it works. There's this nice function called address. And so, like, say we bind A to 10, okay? And then we call address on A. And so it's this complicated hexadecimal representation of where the 10 lives in memory. That's the thing that the name A is bound to. And now let's bind B to the result of evaluating A. And then let's ask for the address of B. And notice it's exactly the same as the address for what A is bound to. And the reason for that is that R is kind of lazy. R doesn't, we're just trying to be efficient. It's not really lazy. It sees that B is supposed to be 10. So it says, I don't need to make a new place in memory, use up more memory to put a 10 in it and bind B there. I'll just temporarily have B point to that same place, that same 10 in memory that A does. And so, of course, B, it evaluates to 10 like we expect. And we can use it in other operations, like we expect. So like B plus 30 is going to be 40. And you go and check and see like where does this thing live that B is bound to, and it's still that same 10, the same one that A is bound to, same address. Yep, same address. But now let's make this change. Let's say we want to bind B to 20. And now we ask for its address. And if you look, it's a little bit different. See how there's a little difference in the ending? Yeah. So the 20 that B is bound to, it's just been a little new place in memory has been created for it, and the 20 is stuck there, and B points there now that it has to, no more ability to save space by having it point to the same thing as A. Value semantics works that way. It creates these separate and distinct copies when it has to keep it straight. Meanwhile, A, it just totally is still in its same place, bound to its same thing. So let's see how it goes, though, with reference semantics. So let's check again on Dorothy's age. I think she's 14. Oh, yeah, she is. Okay. But let's create another Dorothy. Let's bind the name Dorothy to Dorothy, to the result of evaluating Dorothy. Ta-da, there's Dorothy 2. Okay. And why don't we check on the location in memory for both Dorothy and Dorothy 2, okay? So I'm just concatenating together those two addresses. And, again, it's kind of like in value, it's just like in value semantics. Right now, they're both bound to the same thing out in memory somewhere, okay? Now, let's change the age of Dorothy 2 to 30. Okay. And let's check on the age of Dorothy. So, she's 14, right? But whoa, now she's 30. It's like, this is crazy. And, Dorothy 2, I wanted to turn her to 30. I didn't want to turn, like, the old Dorothy to 30 as well. But that's how reference semantics works, is that even after you start, like, manipulating the objects, the new one that you made actually just keeps referring to the same place in memory. Let's check this out. Let's rerun this address commands. They're both referring to the same places. And so now that's a very convenient thing in object-oriented programming for people who are inexperienced in it, but it's a really surprising, nasty thing when you're first encountering the subject, reference semantics. So you might wonder, like, is there a way to make a new Dorothy without having that kind of nasty surprise? And that's where that public method called clone comes in. So let's try making Dorothy 2 this way. She'll be Dorothy $clone. It's called with no arguments. So there she is, and I'm printing her out too. And so remember that Dorothy, got her age changed to 30 on her, so Dorothy 2 starts out that way too. But what's crucial is let's check on the address of Dorothy and Dorothy 2. They're different. And so now, if I want to fiddle with Dorothy 2's age, maybe make her 100 years old, that's not going to affect Dorothy's age. Dorothy's age is still the 30. So clone produces a truly new and different copy that can be manipulated independently of what it was a clone of. There's that's a little bit oversimplified, because if an object actually contains as one of its attributes another object, then when you clone, the clone's going to contain a reference to that member object, and so there'll still be some ability to sort of intermanipulate. So you do want to be careful on that. If you want to make a totally separate copy of one of these complex objects that has objects inside of it, then you're going to have to do something called deep cloning, and that is discussed in the manual on R6. I think that's enough for now. When we get back next time, we'll talk about the notion of inheritance.